Hey YouTube, today we have a challenging repair of a 13 or 19 inch K7000. This is running on a 13 inch tube right now with good P plus, and this was the chassis that had some carnage released when a few components failed. So I'm going to kind of walk you through my approach to this style of problem, and everyone has their own style. Mike out there at Amateur Monitor Repair has a really great list of everything you should check. And honestly, I usually don't do that because very rarely will you see one that's this bad. So I kind of just went through it one by one, not thinking that holistically there were so many parts that were bad. But when I got the chassis, I'm just going to point to a parts chassis here because the flyback's already removed and there was some components here that'll be easier to see. But when I got that chassis that's running from an operator, the fuse was blown, and whenever you see the fuse blown, you have a short somewhere. So what I usually do first is the hot has been removed, but you can check with your meter, go from, there's a glass insulator behind this, so you should go from the tab to the metal frame. You should have no continuity at all. And this one was a dead short. So then I took it out, and this was the one that was failed, but with your meter in diode mode from the center leg to the outside, with one lead on the center, you should get nothing to the outside legs. And if you reverse your leads, you should get a junction or diode drop. And then you'll always have continuity from outside to outside, even on a good one, but you should never have continuity from the center leg to the outside. So this one read as a dead short. Another thing that you want to do is if you read it as shorted in the circuit and you took it out and it was shorted, you should measure that on the pads to make sure that there's also not a second thing that is shorted on there. And sometimes you can get the large film capacitors, like that cow capacitor that's in there. A 25 might have that as two separate ones. And then like your width capacitor, and even I've seen that C37 go shorted, and then that would also cause the fuse to blow right away. And sometimes those being shorted will actually cause the fuse in the cabinet to blow before this one. I've seen that. So everything metered open on that, so I thought it was just a blown hot, hoping to get lucky. And then I installed a good brand new hot and then fired it up, and again, I was watching the B+. Usually my approach to this is for an unknown chassis, I don't throw a signal generator or a video PCB on it because I don't know what it's going to do. I just let it run I turn it on and I monitor the B+ for a couple minutes just to see if it's stable. And then if it's going to pass that first power test, then I'll hook a signal up to it. So I just had it running with no signal, and the B+ was rock solid at 123. So I thought that my voltage regulator was good. It wasn't going into shutdown. Then about 5 to 10 seconds in, there was a decent amount of smoke coming up from this area, and couldn't really tell if it was the flyback or there's components tucked in here too. So immediately turned it off, and then while I was turning it off, I had a fuse breaker on this so that I wasn't going through good fuses. That fuse breaker popped, and then also the fuse on my isolation transformer popped. So if they both are going, something really bad is happening in there. And then sure enough, the brand new hot shorted out again. And then I was kind of thinking, okay, there was smoke from this area. I couldn't really see any burned components. So I was like, well, maybe the flyback is just bad. And this one doesn't show signs on the ring tester of having any shorted windings, but compared to another factory one, I don't have the same rings on corresponding pins. So I think this is now damaged, and there might actually be an open winding in there that could be causing some of this issue. So I took a known working flyback and a known working hot from a different chassis, and I installed it on there, thinking that that is all that was wrong, is the bad flyback was eating up hots. And this is kind of getting into that muddy part of a repair where you can be throwing good parts at bad parts, and every time you throw that switch on, you might be spending about $5 to $10 on parts, because you got to try and figure out what part's bad, and if you haven't replaced it yet, it's going to eat up the new part you just put in. So I turned on the power switch, and again, it seemed fine for a second, and then I saw a little bit of smoke, so I turned it off right away, and no fuses popped there. So then I was pretty much ready to throw this thing at a wall, and then started thinking the flyback was good, so that couldn't have smoked it that fast, and then the hot was good. So I know that those two are causing the problem, and it has to be something from the power supply that's derived off of the flyback. And just with everything installed, I started metering out the diodes that are inside next to this heatsink. And these go into the 24 volt circuit, but it was D13 on that chassis was a dead short. So I just grabbed it off of the parts chassis, this one actually, and then put it back in. And then when I went to power it up, I had high voltage shutdown. So the B plus spiked 170 immediately. Now, if you have a slow high voltage shutdown, a lot of times it's this 47 microfarad capacitor at C57. But if it's an instant thing where you turn it on, it's almost always the voltage regulator that I found. So to defeat that and to check if the voltage regulator is actually bad, you can come over here by the shutdown pot. There's a D10, and if you just lift one of those legs, you'll take it out of circuit and you'll defeat the shutdown. So that means that the shutdown will not function, but the monitor will still run with a really high B+. And you'll have a pretty shitty picture, but you'll still get a picture and you can see if you have deflection and everything. So I lifted one end of D10, fired it back up, and sure enough, the B+ was as high at 160, but I had a picture. And all I had for a picture was one horizontal line. So I know that the flyback was good, the hot's good. Something happened to the voltage regulator as well, and that got knocked out. And I did read on there was 2 pins shorted together. And I don't know if that happened before I started working on it or if it happened during my initial smoke test. But then I also had voltage regulator failure and vertical collapse. So pretty much every major thing that could happen on a K7000 happened on this particular one. So then coming back to the fact that that shorted diode came out of the 24 volt section, which runs your vertical IC, a main culprit of having vertical collapse is this resistor that's tucked behind that diode and next to this capacitor. R91 can go open, and that's pretty easy to check with the meter with it still installed. You can see if you have that 1.2 ohms of resistance or if it's really high. So this was open as well. So I replaced that. Remember, it was still in shutdown, so D10 was lifted, but then after turning it on, I actually had deflection. So then, now that I fixed the vertical deflection, it was just onto the voltage regulator, and after changing that, it was good. So here's just one of those kind of knockdown, drag-out repairs where if you're watching this, you've probably had one of these, and they get pretty frustrating. But again, you kind of have to think about not just, okay, I found one bad part. It would have been wise to check, okay, that was smoked. If it was the flyback possibly causing it, maybe it smoked the voltage regulator. And then those are kind of the expensive parts. The genuine, authentic parts are about $7 a piece, and then the flyback's $30, and then those diodes and resistors are pretty cheap. But it gets kind of expensive to make these repairs, and every time you flick the power switch, it's going to cost you $5 or $10. So hope this helps you out fixing your K7000s.